These are some past HSC questions relating to exercise 403, which is looking at interquartile range and measures of spread. So 2013 HSC question 27. A retailer has collected data on the number of TVs that he sold each week in 2012. Now, remember there are 52 weeks in a year, and this is why this data goes up to 52. So, and he grouped the data into classes and displayed the data using a cumulative frequency histogram and polygon, which is the line graph. Now, notice that 100 is the center of this data. It doesn't mean that exactly, and we can see, remember there's 52 weeks of the year. It looks like this is 7 weeks. It looks like 100 TVs, but it's not exactly 100. That's the class center 100. So if I go down halfway and up halfway, what's halfway between 100 and 200? It's 150. So really what's in between the borders is the 50s, 150, 250, etc. That's what's in between them. So what this really is, 100 is the class center, but it's the center of 50 and 150. See, because if I know that's 100, that's 200, halfway is 150. 250, 350, 450, etc. 550. But the 100 is the class center. So it says, so 52 weeks. So for example, in 7 weeks, there were between 50 and 150 TVs sold, etc. But between 150 and 250 TVs sold is not 22 weeks. It would be 22 minus 7. 15 weeks, and that's an extra 15 weeks. Remember, this is cumulative frequency and it keeps going up. It's the frequency of the first column plus the second column here. And this one is the frequency of the first, second, and third columns together. Okay? So it says use the cumulative frequency polygon to determine the interquartile range. Now 100% of my data is at 52. 52 is the top of the column, the top of the cumulative frequency histogram, not 60. Okay, so 52 is my 100% mark. So 100% is 52. So if I want my median, for example, I know we're just doing interquartile range, but it's good to revise median. The median is at 50% of 52, which is at 26th score. Do we get it? The Q1 is at 25% of 52. So it's a quarter of, or you can halve the 26. A quarter of 52 is the 13th score. And Q3 is at the 75% mark of 52. And that would be, if you do 75% of 52 or 3/4 of 52, that would be 39th score. Okay? So we're going to come across at the 13th score for Q1. We're going to come across at the 39th score. We're really coming with this data. That's 100%. Remember, 26 was at 50%, like the median. The 13th, 1, 2, 3, is Q1. And the 39th score is Q3. So we have to come across with our ruler and read off on the horizontal axis what Q1 and Q3 are. So coming across at Q1, and then coming down, it looks like it's one box before 200. So coming across at the 13th number, 25% mark at 13, hitting the line graph or the polygon, and coming down, I am just before 200. That's one box before 200. The boxes go up by tens. So Q1 is 190. Can we see that? So Q1 is 190. Let's go up to Q3. So Q1 is 190. Coming up to Q3. Coming across to hit the line graph. And then coming down. Actually, not sure if I've come down at the correct spot. So I don't think I've come down. It's a bit hard to see. It might actually be, yeah, I think it's the solid line. I think Q3, from what I can see, is 420, not 4, yeah, no, it's not, it's 470. Because there's 450, it's 2 lines afterwards. That dotted one's not quite right. It's the solid line, 470. And so therefore, the interquartile range is 470 minus 190, which is 260. So we're asked for the interquartile range, which is 260, but we could, if you were asked the median, just the same sort of thing, coming across at 50%, just a little bit hard to see, and then coming down, it's actually not 310 and not 320. I think it's approximately 315. So the median, but you're not asked for it, is between 310 and 320. So if we had to record the median, just by looking at it, median is approximately 315. And you can put a squiggly equal sign. Okay, median is approximately 315. Now, part B, or part 2 of the question, says that Oscar said that the retailer sold 300 televisions in 6 of the weeks in 2012. Is he correct? Give a reason for your answer. Now, let's look at the graph. 300 TVs. The gap between there and there is 1, 2, 3, 4. Oh. Okay. Remember how I was saying before that this column is not exactly 300 TVs. It's between 250 and 350 TVs. So even though, yes, this gap here is from 22 to 28, that is 6 weeks, right? It is 6. So 6 weeks, the retailer sold between, not exactly 300 TVs, but between 250 and 350 TVs. Not exactly 300 TVs. Right? So the answer is no. Oscar's not correct. The retailer did not sell exactly 300 TVs, but he sold between, so the answer is no, he is not correct. Okay? This along here is continuous data. Okay, and it's group data. So 300 is the class center. It is not the actual number of TVs. Do we get that? So it's different if the numbers down the bottom were 1, 2, 3, 4, 5, 6. They would be just individual data. But this is class center. So it is between, you need to say no, he's not correct. The retailer sold between 250 and 350 TVs. 2011 HSC. The sets of data, X and Y, are displayed in histograms here. Now, which of these would you say is symmetrical? Do you think either one of them looks symmetrical? This one's symmetrical because, look, the columns go down equally on either side. This one almost is. If this column was just like that, it would be symmetrical, okay? But the questions are, X has a larger mode and Y has a larger range. What's the mode of X? It's 9. What's the mode of this? And what's the range? 9 minus 3 is 6. And the range is 11 minus 5 is 6. So it can't be A. X has a larger mode and the ranges are the same. That looks good. The modes are the same. That's wrong. And the modes are the same. That's wrong. So it's B. Which of these do you think, and I know the question is not asking this and we've done this in a further exercise. Well, actually, it could be asked in this. Which one do you think's got the highest standard deviation? The mean would be the center of the data. Do you think more of the scores are around the center in graph Y or in graph X? Yeah. So Y also, so something additional, has a smaller standard deviation. And it's not asking that. So y has a smaller standard deviation than x, for sure. Because see how the big columns are right near where the center of the data is? More of the data, so y has more of the data near the center, near the mean, near the center, or near the mean. The mean would be, because this is purely symmetrical, the mean is definitely 8 here. When your data is perfectly symmetrical, the mean is the same as the mode, which is the same as the median. Okay? Whereas in this graph, your standard deviation would be quite large because a lot of your scores are, the mean here might be around there. It probably is, even though this is a bit higher, it might be just here, slightly off center. But most of the scores are away from the mean. So for this graph, most scores are away from the mean, are away from the mean. They're not grouped around the mean. They're more towards the outsides of the graph. So this will have a larger standard deviation. Okay? But the question's not asking that, but it's just a good thing to notice about the graphs. 2010 HSC, question 26B. A new shopping centre has opened near a primary school, and a survey is conducted to determine the number of motor vehicles that pass the school each afternoon between 2:30 and 4. And the results for 60 days have been displayed. The results for 60 days have been recorded, then I should have 60 pieces of data. Let's look at my cumulative frequency histogram. Yes, that ends on 60. That's good. Remember, the cumulative frequency is the sum, like it's, see how this first thing, from 100 to 124, that's the number of motor vehicles that passed. If you add 100 and 124 together and divide by 2, you'll get 112. So that's the class center of the data. That's what they show in the middle. Now, the frequency of that is 10. Can you see? Now, looking at the graph here, I don't have this one, but if I add all these up, what I've got so far, I've got 10 and 20 is 30 and 15 is 45. I'm supposed to have a total of 60. What is the X? I can look at the graph and say, yes, I think it's from 10 to 25 is 15. Or I can add these all up and say I've got 10 and 20 is 30, 45. And I can say 60 minus 45 is 15. So I can do it either by looking at the table and working out this missing value, because I know that the total, or we write sigma f, is 60. Or I can sort of look at this, but looking at the graph is not very accurate. So X is 15 definitely. Now, you need to draw the cumulative frequency polygon by joining the straight lines to the tops of each corner. And then you need to read off, you're going to have to work out your, draw the histogram which we've got, and draw a cumulative frequency polygon which we've done. Starts at the bottom, joins the top corners, and then you have to use your graph to determine the median. So graph to determine the median, so we've got 60 scores. So for the median we come across at half of 60, which is at 30. So 50% of 60 is the 30th score. We come across at the 30th score on our graph. And we come down. And we need to estimate what this value that we come down at is. Now, this working out the median is only worth 1 mark. So we came across at the 50 percentile mark and we come down. Now we know that this class center of 162, that the values range from 150 to 174. So it's really, if this is about 150 there, and this is about 174, we're looking roughly between 150 and 162. Looks roughly halfway between 150 and 162. So we can just take an average of those two values. So the median is approximately the average of 150 through to 162 divided by 2, and we get approximately about 156. So median is approximately 156. Now that's just an approximation. And part 4 says prior to the opening of the new shopping centre, the median number of vehicles was 57 between 2:30 and 4. Well, the old median, so for part 4, was 57, and the new median is approximately 156. So therefore the number of vehicles has almost tripled. So what problem could arise from the change in the median number of vehicles passing the school before and after the opening of the new shopping centre? So the number of vehicles has almost tripled. It'll be a lot more traffic around the school, so a lot more traffic around the school. You know, there would be, you know, that's quite dangerous for students, increased chance of accidents, really. And so a solution to this problem, hopefully there already is, there could be a person, the lollipop person, so lollipop person, maybe at a crossing, or we could have, just to make sure that there is a crossing, so making sure that there is a crossing, lollipop person at crossing, additional supervision, you know, additional supervision around the school at crossing areas. And of course, you'd have to make sure that the speed limit is enforced. Speed limit of 40 must be enforced. Okay.